Hey, welcome back. So this is test one review for Trig, and test one covers chapter 4. So basically I'm going to go through and remind you of the things you kind of need to have memorized, and excuse me, the test will be written out, so you'll have to log into WebEx, try to get there a little bit early, and I'll post the test in Blackboard, and you'll download it to your computer and print it out. And before I let you download it and print it out, I go through and I check everybody and make sure I can see so I have to be able to see your work area while you take the test. Okay, so you need your webcam pointed down at your hands. So I know you're able to do this. I could do this with my laptop. So, ideally you would have a webcam, and if you really want one, you could buy one online for like 30, 40 bucks, and that makes life a lot easier. But if you don't have that, you don't have the money for it, I get it. You could still kind of like tilt your webcam down so I'm able to see your writing area, and then when you read off the screen, if you can't print your test out, you're just going to have to kind of bend your head down and look at the screen and read the questions that way. You'll have to record all of your work. So obviously if I don't see any work, I can't give you a grade. If you're just writing answers, I'm going to be like, oh, I don't know about that. This person probably cheated. So you have to show all your work. It should, literally the work should be kind of the way I'm doing my work here. I can't. So if it looks like somebody else took the test for you, again, I can't give you credit for it. So hopefully you've been paying attention, watching the videos, doing your homework, especially my videos. And, that's why I do those little quizzes, those video quizzes, so you watch the videos. Right, so, you'll go into WebEx. I'll go through one by one and the students and check out your scratch paper. So I need to see all your scratch paper front and back. I need to see your calculator. There's no graphing calculators, so it's scientific only. I need to make sure that your webcam is pointed so I can see your hands, so that none of this one hand on the screen, one half off the screen. I'm not an idiot. There's no more cheating, okay? I know the pandemic was hard, and maybe some teachers maybe didn't enforce the rules so well, but, it happens, and we have to get back to our pre-pandemic stage of academic integrity, or pre-pandemic state of academic integrity. So anyways, you'll do the test. Once you've written out the test, you'll like tell me you're done with the test, and I'll give you permission to start taking pictures and uploading your work into the computer, just like you did with the video homework. You must have a way of doing that now, and then you'll send it to my email. Once I get it in my email, or once you send it, tell me, and then I'll let you go. Once I have it in my email, I'll send you a message. I have it. You're good to go. That sort of thing. Okay. Okay, so I'm not giving you any notes on this. You have to have a lot memorized. There is a ton of stuff, and I'm hoping that this video will kind of, beat that into your head, what you need to have memorized, what topics you need to know. So it might be a good idea to have your book open. The questions on the test, I write them the same way that they're written in the book. I take them word for word from the book. And let's go in here and start. If I think of anything else, I'll kind of remind you. But 4.1, I'll be taking problems from 13 to 73 odd, and sometimes even the even numbers, I'll take those. You got to know how to convert between radians and degrees. So this radian degree conversion, and of course for that you need to know the conversion factor, pi over 180 or 180 over pi, right? You need to be able to draw the angles and their standard positions, but you need to be able to go basically walk around the unit circle with your angles. So recall basically, in the homework you would have seen things like this, right? So this angle would be pi over 6. Of course, this would be 0, and then pi over 4, and then 2 pi over 6, which is just pi over 3. And of course, in this direction, it's positive. In the other direction, it would be negative. I'm just going to do positive, one positive rotation. This would be pi over 2, which is also 2 pi over 4. This would be 2 pi over 3, which is also, what is it? 1, 2, 3, 4 pi over 6. This would be 1, 2, 3 pi over 4. And then this would be 5 pi over 6. And then 6 pi over 6, which is just pi. 7 pi over 6. 3, 4, 5 pi over 4. 2, 3, 4 pi over 3. Which is also 9 pi over 6. And then 3 pi over 2. And then 5 pi over 3. And then 7 pi over 4, and then this would be 11 pi over 6. So you should be able to walk around the circle and do that. You should have some notion of what a coterminal angle is. So like 11 pi over 6 and negative 11 pi over 6 are the same. 11 pi over 6 and negative pi over 6 are exactly the same. They're coterminal. Okay, so coterminal angles. What else did we look at? Was that about it? Length of a circular arc. It's a lot of stuff. So if you had a circle and you kind of know the angle in here and you know the radius, you could figure out the length of the arc, which is this distance around the circle. It's the standing room only formula. And okay, so let's take a look at some of the problems from the book. And number 19, and this is on page 532, again, if you want, page 532. If you want to pause the video, get your book out, whatever. Anyways, number 19, what do we want to convert from degrees to radians. So I have negative 225 degrees. Okay, so to convert over, I need my factor. I'm going to put the degrees in the bottom, 180 degrees, and the radians on top, so the degrees kind of cancel each other. Okay. I'm going to have to simplify this. I'll end up with negative 225 over 180. You can divide each by 5. Okay, so that would be negative 45 over 36 pi. And then I could divide both of those by 9. So get negative 5 over 4 pi. And I still only wrote 6. That's negative 5 over 4. Okay. So you should be able to reduce fractions. Please reduce your answers in this part. Let's look at one where we go in the other direction. So 25 from radians to degrees, so 7 pi over 6. This time you just take the reciprocal of your factor from above, so make it 180 over pi. The pi's cancel. 7, basically end up with 7 times 180 over 6 degrees. 6 goes in the 180 30 times. 7 times 30 is 210 degrees. Okay. There's 41 to 55. They want you to use the circle to draw the particular given angle. So number 45, they want you to draw negative 2 pi over 3. Okay. And so the circle they give you is like what I was showing you there in the beginning with the little stupid marker. With these 1, 2, 3, 1, 2, 3, 2, 3, 1, 2, 3. Okay, so negative 2 pi over 3, going in the negative direction. Here is 1 pi over 3, and then negative 2 pi over 3 is right here. So you just draw that terminal side and label it so I know that's what you mean as your answer, and then you're good. Okay. 59 is on coterminal angles. So the questions are: find the positive angle less than 360 degrees or 2 pi that is coterminal with the given angle. This question is about degrees, so find, the angle less than 360 degrees coterminal, and they want the positive angle. Find the positive angle less than 360 coterminal with negative 150 degrees. Okay. Okay, so in this case, it seems you could just take negative 150 and keep adding in multiples of 2 pi, right? So I'm going to add in 360, and that'll give me, if you start with 210, and then 210 is in between, 0 and 360. So when they say find an angle less than 360, they want some angle x less than 360. It has to be positive. That means it's greater than 0. Okay. Okay, so 210 is in between 0 and 360, so that must be your answer. Okay. Okay, 71, let's see what they say. Find the length of the arc on the circle and of radius r intercepted by a central angle theta. Express arc length in terms of pi, then round your answer to 2 decimals. So they give you the radius is 12 inches, and then they give you the central angle is 45 degrees, and they want you to find the arc length of that. So here's our circle with radius 12 inches. This is 12. And then they're saying this angle theta is 45 degrees, and you have to figure out this length. Okay. So you need the formula, standing room only. The thing about this formula to remember is that the theta has to be in terms of radians. So you can't just plug in 45 degrees. So what you need to do then is to convert 45 degrees. That's like your first step, really. You may remember 45 degrees is just pi over 4. Otherwise, you have to do the converting factor. But if you remember it, you can just write s is 12 times pi over 4. 4 goes in the 12 3 times, so s is equal to 3 pi. And that would be your answer. The arc length is 3 pi units. Okay. They want around, express your answer in terms of pi, and then, so make sure you're reading the question so you know how to, they also want a decimal in the book, but if I don't have to pull out my calculator, I'm not going to, so I'm just going to leave it there. But make sure you're reading the questions and you answer them, and answer all the little bits and pieces. Okay, so anyways, 4.2. Let's scroll over to there and see what page we're on. 4.2, the questions start on page 547. And I'll be taking questions from 25 to 37 and 71 to 79, okay, even or odd. Okay, so what did we learn in this section? We learned about even and odd functions. In particular, sine is odd along with cosecant. So it's, and also then tan and cotan are also odd functions. Usually I just have you memorize that cosine is even and sine is odd, but so sine of negative t will end up being negative sine of t, in other words, and then cosine of negative t will pop out being just positive cosine of t, the even odd sort of identities. Then you had the reciprocal identities, and these are identities I would take for granted that you would know and have memorized, but just for the sake of completeness, let me list them. So sine of t is equal to 1 over cosecant t. Cosecant t is equal to 1 over sine t. Cosine of t is equal to 1 over secant t. And cosecant t then, or secant t rather, secant of t is then 1 over cosine of t. And then tan of t is equal to 1 over cotan t. And then cotan of t is equal to 1 over tan t. So definitely, my physics teacher said 5 minutes after you're dead, you should still remember these identities. That's how important they are. And along goes then our, what do they call these, quotient identities. Again, you should have these embedded in your brain so that 10 minutes after you're dead, they're still there. So cosine t all over sine t, and then cotan, of course, is just its reciprocal. Cotan t is, whoops, and I got that reversed. This is sine, cosine over sine. Cosine t over sine t, sorry. And then this is, I did it again. Jeez. So this is sine t over cosine t, and the other guy is cosine t over sine t. Okay. Then you had the Pythagorean identities, so just tons of junk, right? Pythagoreans. Really, the most important one is a sine squared t plus cosine squared t equals 1. Because you could divide through and then use your quotient and reciprocal identities in order to get the other two formulas. So if you divide by cosine squared, you end up with tan squared t plus 1 equals secant squared t. If you divide through the original equation by sine squared t, you get 1 plus cotan squared t equals cosecant squared t. Finally, then, there's kind of these let's see what they called them in the book. Repetitive behavior identities. So basically, if you have sine of t and then somebody tacks on some multiple of 2 pi, so they'll write 2 pi n, that's just equal to sine of t. Okay. And then if you have cosine of t plus some multiple of 2 pi n, that's just equal to cosine of t. And then for tangent, it's just multiple of pi. So if you remember the graphs and their periods, it's kind of related to their period, right? So this will just be equal to tan of t. Okay, so an awful lot to memorize. Again, flashcards, definitely. So anyways, let's look at some of the problems in that sort of range of problems. So let's get 27. Let's see what we got. Sine and t of cosine t are given. Use the identities to find the other trig functions, rationalized denominators. So on my test, I don't care if you rationalize denominators. I don't really get into that. But sine t is equal to 1 over 3. And then cosine of t is equal to 2 root 3. I mean, you should be able to rationalize numbers at this point, but I'm not going to require it. So this is 2 root 2 over 3. So we just need to basically fill out this chart. Right? Okay, and they give us the first two, and you use the identities to figure out the rest. So this is 1/3. We said 2 root 2 over 3. Okay, tan is just going to be long story short, it's just the numerators, right? So it's going to be 1 over 2 root 2. If you don't believe me, sine divided by cosine is 1 over 3 divided by 2 root 2 over 3. Division is the same as multiplying by reciprocals. So this will be 1/3 times 3 over 2 root 2. And then the 3's will cancel, and you get 1 over 2 root 2, which is what I have. Okay. Zoop. Okay, for the other ones, you could just take reciprocals. So this is 3. This is 3 over 2 root 2. And then this is 2 root 2 over 1. And that's good enough for me. You don't have to rationalize. Okay, 31. So this one's a little different. Same idea though. Find some unknown stuff from some given information. So use the Pythagorean identity to find cosine of t, given that sine of t is equal to the square root of 39 over 8. Find cosine t using Pythagorean identity. So our Pythagorean identity that has both sine and cosine in it will be sine squared t plus cosine squared t equals 1. Okay, so plug root 39 over 8 in for sine t, and then square it. Right? So you get square root 39 over 8 squared plus cosine squared t is 1. Square root of 39, square root of 39 is just positive 39. All over 8 times 8 is 64. Sine squared t equals 1. Plus, and then I'm going to move that guy over there. Okay. One fact you need to know is that the t value is in between 0 and pi over 2. Okay. In other words, the angle is in the first quadrant, which just means that when you solve for cosine, you can disregard the plus minus and just put plus. Okay, that's all it means. So anyways, moving on. Cosine squared t equals 1 minus 39/64, which is the same as 64/64 minus 39/64. In other words, cosine squared t is equal to, I think it was 25 over 64. And then let's take the square root on both sides, so cosine t is equal to 5 over 8. Usually it'd be plus or minus, but because you're in the first quadrant, cosine is positive, so you just get positive 5/8 as your answer. Okay, let's look at some of these problems in 71 to 79. So in particular, let's look at 73. And in these problems, they say before I write out the problem, let sine of t equal a, cosine of t equal b, and then tan of t is equal to c. So then you rewrite the expression in terms of a, b, and c. So you should have seen homework in my math lab like this. So 73, 4 cosine of negative t minus cosine of t. Okay. So here you want to use your identities, in particular the even-odd identities. Cosine of negative t is just cosine of t, and then minus cosine of t. And then you could replace cosine t with the letter b, so 4b minus 1b, and that will just equal 3b. Okay. Let's look at another one, maybe one that's harder. I guess 77 is a little harder. Sine of negative t minus 2 pi minus cosine of negative t minus 4 pi. Okay, so what do we got here? First, we could use the repetitive behavior identity to rewrite this as sine negative t. Basically, you could just throw out anything that's a multiple of 2 pi. And then minus, again, you could just throw out the 4 pi part, and you got cosine of negative t. Then you use your even odd identities. Sine of negative t is equal to negative sine of t. And cosine of negative t is just cosine of t. And then we could substitute in the a and b. So we have negative a minus b. Okay. I think I lost part of it. There's actually in the book, there's a minus tan of negative t minus pi, so let me just do that as well, tack that on. So this would be minus tan of negative t, because if you have any multiple of pi, you can just toss it in the trash. And then over here, this would be minus, it would end up being plus tan of t, because tan is going to be odd as well. The only one that's even is cosine and secant. Everybody else is odd. So you would have to rewrite it as negative tan, but it's negative out in front already, so it's negative negative tan, which should be plus tan, and so you would end up getting negative a minus b plus c. Okay, so that's 4.8 to 4.3, let's get a page number for that. Find one. Page 560. Okay. Looking in particular at problems like 1 to 19 odd. And what did we do in this section? We did the right triangle definitions for your trig functions. Which again, you should have memorized 5 minutes after you're dead. So sine of t is opposite over hypotenuse. Cosine of t is adjacent over hypotenuse. Tan of t is adjacent over opposite. Cosecant t, that is just h over o. Secant t is just h over a. And then cotan of t is O over a. Okay. What else did we do? Pythagorean theorem for just plain old triangles. So if you have your triangle, here's my theta, and we're going a, b, and c. A squared plus b squared is equal to c squared. Okay, so we should know that. And then we should know all the basic first quadrant, pi over 4, sine of pi over 4, cosine of pi over 4, sine of pi over 3, all of those guys. Okay, so we should know sine of pi over 4, cosine of pi over 4, sine of pi over 3, cosine of pi over 3, sine of pi over 6, and cosine of pi over 6. And of course, you know all this if you have that chart memorized that I introduced. Let me remind you of that chart. So how did that go? It was theta, sine of theta, cosine of theta, and then tan of theta. So if you just have this thing memorized, that'll get you through a lot of bad days. So theta going from 0, and then pi over 6, pi over 4, pi over 3 to pi over 2. And maybe as soon as you get your test, just do a brain dump onto your paper and write this out. Write out everything you really need, and it's like basically the whole page of formulas you can have memorized and write out. But you have to have it memorized because you'll get more and more stuff being built on top of this, and you'll just be overwhelmed if you don't have it memorized. You just won't be able to function. You'll just be everything built on a castle made of sand or whatever it is. But anyways, how does this go? 0, and then you have some fractions to 1. Fractions all over 2, and it goes 1, 2, 3, but square roots, right? And then it's just reverse for cosine. And then tan is the ratio of the ones above it. Okay, but yeah, you should. If you have that table memorized, then you know all the sine, pi over 4, or sine, all that junk. Okay. Okay, let's take a look at the kinds of problems we're looking for here. Number 3, use a Pythagorean theorem to find the length of the missing side, then find the volume of each of the 6 trigonometric functions of theta. Okay, so let's try this guy. Number 3. So they give us some information here on the triangle. And what is the information? So 29 for the hypotenuse, and one of the legs is 21. So first I have to use Pythagorean theorem, and then I got to go through and figure out, the sine, cosine, all that jazz. Right? Okay, so a squared plus b squared equals c squared. So we have a squared plus 21 squared equals 29 squared. So a squared is 29 squared minus 21 squared. And then take square root on both sides. A is equal to square root of 29 squared minus 21 squared. Go to your calculator. This is the same as a square root of something. I'm not sure. I think it's 400. And then that'll equal 20. So your third side is 20. So we could fill that in. And then you just use your right triangle definitions to fill in all of the trig functions. So sine is opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, and then flip them all. Okay. Let's see what else. Let's try number 15. Let's see how it goes. So use the given, or use what you know about the first quadrant angles to evaluate the given expression without a calculator. So sine of pi over 4 minus cosine of pi over 4. Okay, so again, if you have the chart down, you have it. So sine and cosine of pi over 4 are the same. So this should just be 0. Let's get another one. So 18. This one is cosine of pi over 3 times secant of pi over 3 minus cotan of pi over 3. Okay. So cosine of pi over 3 is just going to be 1/2. Secant is 1 over cosine, so that's just going to be 2 over 1. And then cotan is 1 over tan. And tan of pi over 3 is root 3 over 3, so you're going to end up with 3 over root 3, which will turn into eventually, sorry, what am I saying? So it's cosine over sine. It's 1 over, it'll be root 3. Okay. So it's 1 over, if you look at tan for pi over 3, that's root 3, and then cotan will be 1 over root 3, sorry. Cotan of pi over 3, did I screw something up? I don't think I did. Yeah. Tan is, so this would be 1 over root 3, sorry. Okay. So 1/2 times 2 over 1 is just 1, and minus 1 over root 3, and you can leave your answer like that, unless I ask for a decimal. Okay, so make sure you're reading the questions. Okay, so good enough. 4.4 then is a lot of that using your original angles kind of as reference angles to evaluate trig functions, and then you just have to know the sign of the trig function and the particular quadrants. So in particular, problems from 4.4 like 35 to 85, but also you should be able to answer all these 4.2 problems. It was kind of weird the way they introduced it, and basically these are just become 4.4 problems once you have everything memorized. So I also include them in this section. Okay, so what did we learn here? Well, a smart trig class, right? So the quadrants and the signs of the trig functions, so they're all positive here. Sine is positive here. Tangent is positive here, and then cosine is positive here. Okay. And what else did we learn? The reference angle, how to find reference angles. So that process was kind of like a subtraction. So reference angle, if it's in the first quadrant, there's nothing to do. But like if it's in the second quadrant, to find the reference angle, you have to go 180 minus whatever the given angle is, right? So theta prime would be pi, or 180 minus theta. And what were the other ones? So here in order to pull that one off, the reference angle inside here, as opposed to the big angle, would be the big angle minus 180, or pi. And then finally in the fourth quadrant, you have something over there. The reference angle here would be, I guess, just 362 pi minus theta. Okay, so theta prime would be 360 minus theta. Okay. Okay, and then we should be able to evaluate trig functions, and that 4.2 stuff, that's pretty much all you're doing there is evaluating trig functions. Okay. Okay, so let's dive in here and look at some of these. We'll start with 4.4, just finding reference angles. So find the reference angle. And we're looking at 38. We have 210 degrees. So find where 210 degrees is. Here's 180. This is 270. So 210 is in the third quadrant. So in order to get our reference angle, theta prime, we have to take 210 and subtract away 180. Okay. So that's just going to be 30 degrees. Circle it, make sure I can see it. My zeros kind of look like sixes. Make sure I can read it. Okay, let's look at 56. Same problem, but now in radians, 17 pi over 3. 17 pi over 3 is almost 18 pi over 3. 18 pi over 3 is what? Well, that's 6 pi, right? So 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi is basically right here. Okay, so what is that? That's, what did I say, 18 pi over 3, which is 6 pi. And then 17 pi over 3 is just 1 pi over 3 less. So that must be in the fourth quadrant. Okay. So in order to get our reference angle, you can take basically the 18 pi over 3 and subtract away 17 pi over 3. That's one way to do it. The kind of trick I used in the videos was just to kind of look at the denominator and make sure it's simplified, and that kind of tells you the reference angle is just pi over 3. Okay, but if you wished, you could take 18 pi over 3 and subtract away the 17 pi over 3, and you'd get pi over 3 as well. Whatever gets the job done is kind of what I'm saying, but please show work. So I think the more standard way of doing it in the book, I'll just mention it then, would be to get this into kind of between 0 and 2 pi, right? So in order to pull that off, what you're doing is subtracting multiples of 2 pi. So you subtract 2 pi, which is really 6 pi over 3, and you would get 11 pi over 3. If you subtracted another 2 pi away, what we would have another 2 pi, that would be 6 pi over 3, that would be 5 pi over 3. Okay, so finally that's in between 0 and 2 pi, so that would be 1, 2, 3, 4, 5, it's in the fourth quadrant, 5 pi over 3, and then to get the reference angle for something in the fourth quadrant, it will always be 2 pi minus 5 pi over 3, which would be 6 pi over 3 minus 5 pi over 3, which would just be pi over 3, which is what I sort of guessed at in the beginning. Okay. Hopefully that wasn't overkill. I apologize if it was. Let's move on now to actually evaluating these things. And it's kind of a two-step process. So first you have to find the reference angle and then find the sine of the function in that particular quadrant. Okay, so let's look at like 61, and we're trying to figure out the cosine of 225 degrees. Okay, so 225, is in between 180 and 270. So I guess maybe the first step should always be make sure it's in between 0 and 2 pi, or 0 and 360. This one it's in the third quadrant. To get the reference angle then, you're taking 225 and subtracting away 180. So you get 5. I'm going to have to borrow So this would be 1, 12, 8, 9, 10, 45. So the reference angle is 45 degrees. Cosine of 45 degrees is root 2 over 2. And then cosine is negative in that quadrant. So your answer is negative root 2 over 2. This process is really important, so I'm going to beat it to death and put a whole bunch of these problems in on the test. 69 cosecant of 7 pi over 6. Okay, so where is 7 pi over 6? 1, 2, 3, 4, 5, 6. It's in the third quadrant. The cosecant is basically 1 over sine, so it's negative, whatever the answer is. The reference angle is pi over 6. Sine of pi over 6 is 1/2, so cosecant is 2. So you get negative 2. 71, tan of 9 pi over 4. Okay. So that is a little out of 2 pi, right? That's just 1 pi above. If you think about it, you can kind of, well, it's right here, right? The reference angle is pi over 4. Tan of pi over 4 is 1. 9 pi over 4 is in the first quadrant. So, if you count around 1 pi, 2, 3, 4, 5, 6, 7, 8, 9. If you want to, you can, subtract away 2 pi and then go through the whole rigmarole and find the reference angle. But it's better just to think of the reference angle. You kind of look at the denominator so long as it's reduced and say, because I mean, if you had the tan of 8 pi over 4, the reference angle wouldn't be pi over 4, right? The reference angle is just 0. 2 pi is 0, basically. So tan of 0 would be 0. So you got to be careful with kind of just guessing the reference angle, but usually it kind of works. Anyways, again, tan of pi over 4 is 1, and tan is positive in the first quadrant, so it's positive 1 is your answer. 81, cosine of 23 pi over 4. It's probably best to get that back in between 0 and 2 pi. So you're, 0 and 8 pi basically. So you're subtracting away multiples of 2 pi. 2 pi is the same as 8 pi over 4. So this will end up being 8. Was it really 15 pi over 4? That's still bigger than 2 pi, so we can subtract away another 8 pi over 4. That's going to give you 7 pi over 4. And that is in the fourth quadrant. It's positive, and the reference angle is pi over 4, just looking at the denominator. So it'd be root 2 over 2 is your answer. Okay. And if you needed to, you could literally count around to it, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 19, 20, 21, 22, 23 is in the fourth quadrant. Okay, good stuff. Let's look at another one about, okay, so let's go back to the 4.2 problems. And these are basically just more of these problems like 71, 81, 61, and 69. Okay, it's just more of those for practice. So let's look at 7 and 4.2. Cosine of 5 pi over 6. Okay, so 5 pi over 6 is a little less than 6 pi over 6, which is a little less than pi. Okay, so the reference angle, of course, just looking at the denominator, is pi over 6. And so cosine of pi over 6 is root 3 over 2. And in the second quadrant, cosine is negative, so that would be negative root 3 over 2. 11, cosecant of 7 pi over 6. So cosecant is basically sine, 1 over sine. Where is 7 pi over 6? So that would be 1 more than pi over 6, which is right here. The reference angle, of course, is pi over 6. You could just tell from the denominator. And then Sine of pi over 6 is 1/2. So cosecant is just 2 over 1. And sine is negative in that third quadrant. So the answer would be -2. Let's look at another one. We'll just do 2 more, then we'll move on. But this is kind of important that you master this for the future generations. 3 pi over 2, where is that? 1 pi over 2, 2 pi over 2, 3 pi over 2. That will be -1. Okay. So if you think about it on the unit circle, that would be at position 0, -1, and sine is always basically the y coordinate. So y over the radius, but if it's a unit circle, the radius is 1. So -1 over 1 is just -1. Okay. So, all right. Let's look at 17. Secant of 3 pi over 2. Okay, secant is really the cosine, and cosine at 3 pi over 2 is 0. Okay. So if you think about the coordinate there, the x-coordinate is 0, so cosine of 3 pi over 2 is 0. So secant will be 1 over 0, which will be undefined. So there are some like that are undefined. And, just got to be careful. Okay. Okay, so you should know not just those interior pi over 6, pi over 3, pi over 4, but you should know like sine of 0, cosine of 0, and of course that's in that table. If you look at that table, you have 0 and pi over 2 involved in it. There's 0, there's pi over 2. But you should also know then kind of the pi over 2, and then cosine of pi over 2, and then sine of pi, cosine of pi, and the 3 pi over 2, right? And then sine of 3 pi over 2, cosine of 3 pi over 2, and so on, right? So, I don't know, sine of 2 pi, but that'll just bring you back to where you started, cosine of 2 pi. Right, so that will just bring you back to these guys. Okay, so just going through those really quick, like 0, 1, 1, 0, 0, -1, -1, 0, 0, 1. Okay. And it's all just based off the coordinates as you go around. So you can see kind of the coordinates 0, 1 on the first two. And then this coordinate is 1, 0. And then this coordinate is whoops, I screwed that up. I got them reversed, sorry. So this is 1, 0. So it's 1, 0 kind of going in that direction. And then the next coordinate is 0, 1. Sorry. Thought I was on to something cool. -1, 0. And then, what is this guy down here? 0, -1. 0, -1. And then back to 1, 0. So hopefully that makes sense. It's based off the unit circle. So you should know all those. Those should be in your memory 10 minutes after you've died. Okay, okay, great. 4.5 then. I'm not going to put, well, I did put, okay, 4.5. Did I do 4.4 yet? I just did 4.4. But 4.5 is on graphing. Okay, and obviously my math lab was pretty easy to do this, but you're doing it by hand takes a little more work. And I need to see the work. So 4.5, I'm looking for where it starts. Okay, it's page 595, so 4.5, page 595. Okay, so what did we learn here? And I'm looking at questions similar to the 7 to 29 and then 35 to 51. We learned how to graph y equals a sine of bx minus c plus d, and then y equals a cosine of bx minus c plus d. So the process, first you get your amplitude, which is always the absolute value of a. If it's negative, it flips the graph about the x-axis. Secondly, then you get the phase shift in the period. So basically you're wedging the bx minus c in between 0 and 2 pi and solving. So we'll have bx greater than or equal to c, less than or equal to 2 pi plus c, and then you divide by b. So x less than or equal to 2 pi over b plus c over b. The phase shift is c over b. The period is 2 pi over b. And then thirdly, the key points. And kind of the way you think about it, you're always going to start at the phase shift. You start there, and then you add in the period over 4. Okay, so 2 pi over b over 4 is 2 pi over 4b, which will end up being c over b plus pi over 2b, and then you just keep on adding in, you find a common denominator, and then 2c over 2b plus pi over 2b, and you keep adding that in, and you'll get your 4 key points on your graph. Okay, so let's see if we can pull this off for at least 2 examples. I probably won't do any where you have to shift up and down, but I think those are kind of, you can handle that if I did. Anyways, 25, let's look at that one. Y equals negative 2 sine of 2x plus pi over 2. So that is a negative. Okay, so first off, the amplitude, and it's not negative 2, right? It's the absolute value, and it's 2. Then your period and your phase shift, if there is one. So you're taking the stuff inside the sine function here and wedging it in between 0 and 2 pi. Okay. And then you're solving. So subtract pi over 2 from all 3 sides. Divide everything by 1/2. In other words, multiply everything by 1/2. You get negative pi over 4 less than or equal to x less than or equal to pi minus pi over 4. So I keep them separated so I can see clearly what the period is. You could, if you want to, just subtract this, and what you'll end up with is this, which is the period. Okay, so that's the period. This thing over here is the phase shift. Okay. And then for the key points, you have to start at the phase shift. Okay. So you start at negative pi over 4, and then you're adding in the period divided by 4. Okay. So start here, and this is how you move for your tick marks. Okay, in this question, they're only asking for 1 period. Okay, so I'll come over here and kind of do that. I'm starting at negative pi over 4, and I'm moving by pi over 4. So 0 pi over 4, and then 1 pi over 4, and then so 1, 2, 3, and then here. So this would be 0 pi over 4, 1 pi over 4, 2 pi over 4, and then 3 pi over 4 would be 1 full period. Okay. The amplitude is 2, but it's upside down. That negative in front of the 2 flips it upside down. Okay. So it's a sine curve, so instead of going like this, it's going to be going down. And you could, put your key points in there if you want to. Here's 1, 2, 3, 4, and then back to where we started. And then connect the dots, and that should be 1 full period. Okay. Yeah, kind of missed the mark on that one. Okay, and of course it goes on and on forever in both directions, but all we need is 1 period, so there's that. Okay, let's try another one. This time we'll do a cosine, and again we only need 1 period. I'll tell you on the test how many periods you need. Y equals negative 1/2 cosine of pi over 3x. Okay, so first the amplitude is just positive 1/2, and there, of course, again, there's going to be another flip about the x-axis because of the negative. Secondly, then, the phase and the period. So you just wedge the pi over 3x in between 0 and 2 pi. Then you're going to have to multiply by 3 over pi on all 3 sides. So I'll have 0. So basically there's no phase shift. And then x, then less than or equal to the pi's cancel, and we just have 6. Okay. And then to get the key points, and if I did not notice that the period is 6. Okay. And again, you could always just kind of subtract the 2 endpoints of this interval, but the period, in this case, if I did not mention it, is 6. So you need to tell me what the period is. If there's no phase shift, you don't really need to say it. But, okay, so the key points, you're going to start at 0, that phase shift, and then you add in the period over 4. So you're going to be going by 3 all over 2 every time. Okay, so let's get 1 period going. 1 3 pi over 2, 1 3 over 2, 2 3s over 2, so 6 over 2, 3 3 over 2s, which will be 9 over 2, and then 4 3 over 2s, which is 12 over 2, which of course better equal, your end of the period 6, which it does. Okay, put the negative 1 and 1 here. Our amplitude is just at negative. Is 1/2, positive 1/2, but it's upside down. So our first key point above 0 is at negative 1/2, and then it's going to go here and then here, making the cosine shape. Okay. And then we can flesh it out. In all of its glory, there's 1 period. Okay. Okay, 4.6 then was on tangent, secants, and cosecants and cotans. I'm just going to focus on tangents, so problems like 5 to 11, where we're just graphing y equals a tan of bx minus c. Okay, so I'm not going to put anything crazy like a cosecant on there to throw you off your game. You got enough to do, right? So how did these work? First off, we got the amplitude. Again, it's just absolute value of a. That would help you get the key points on your picture. Then secondly, you would have the period and kind of the phase again. I don't know if the book really called it like that, but anyways, in this case, you're going to wedge the innards of your tangent function in between negative pi over 2 and pi over 2, and then solve that, and you'll end up with, in this case, multiplied by 1 over b, the sort of starting place, then maybe I should call it a phase shift, but you're going to start with your first asymptote at negative pi over 2b, and then you'll start putting in your key points by moving by c over b over 4, pi over 2b over 4. So actually the starting place then is negative pi over 2b plus c over b. It's always just this thing. Okay. And then the period, which you should mention, is going to be, and I'll remind you on the test everything I need, pi over 2b. And then, is that and then sort of the key points. You're going to start at the negative pi over 2b, and that'll be your first asymptote. And then you'll move by pi over 2b over 4, which is the period over 4, which not being pi over 2b over 4 is pi over 8b, I believe. Okay. And there's a mistake in my notes. Okay, but anyways, let's look at an example, and hopefully it'll make it clear. This time we want to graph 2 periods. So number 9, y equals negative 2 tan of 1/2 x. So first the amplitude is 2. The negative is going to flip the curve from looking like this to looking like this. Okay. That's what the negative does. Secondly then, sort of our phase and period. So I'm wedging 1/2 x in between negative pi over 2 and pi over 2. You technically can't include the endpoints because those are going to be your asymptotes. Multiply everything by 2. Okay. You can find one full period by subtracting the endpoints there. But anyways, we're going to start at negative pi. And the period will be pi minus negative pi, which will just be 2 pi. And so for our key points, we're going to have start at negative pi and then add in the period, which is 2 pi all over 4. So you're starting at negative pi and you're moving by pi over 2. Finding a common denominator, you're going to start at negative 2 pi over 2 and then go to 1 pi over 2 and then go to 0, etc. Okay, so let's get a picture. So I'm starting at negative 2 pi over 2, which is just negative pi, but I'll write negative 2 pi over 2. And then I'm moving by pi over 2s. Negative pi over 2 plus pi over 2 is negative 2 pi over 2 plus pi over 2 is negative pi over 2. And then it'll go to 0, then it'll go to pi over 2, and then it'll go to 2 pi over 2, which is pi. And then we want another period, so the first point would be at 3 pi over 2, and then 4 pi over 2, and then 5 pi over 2, finally ending at 6 pi over 2 with the second period. So our asymptotes here, and then our amplitude is 2, and everything is upside down. So the first key point would be right here, and then right here, and then down here, and then you have an asymptote. Key point here, 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 asymptote, and then draw your graphs. And it should be concave up and then kind of concave down. I sort of butchered it. I'm needing to blow my nose. I don't think I'm going to be able to pull this off. Kind of like that. Okay. Kind of like that. So there's 2 periods. Okay. 4.7 is on inverse trig functions. So I'll be focusing on problems like 1 to 17 and then 63 to 71. What you're doing here is finding exact values. So evaluating like the sine inverse of 1, what does that equal? And you kind of need to know then the range, the output of these functions. So remember, sine inverse is negative pi over 2 to the pi over 2. Cosine inverse is then 0 to the pi, and then tan inverse. These are the only three that I really expect you to know. Negative pi over 2 to pi over 2. I would blow my nose, but there is no Kleenex over where I'm sitting. So I apologize on that. Can't believe there's no Kleenex. I don't know what happened to it. Okay, it's like somebody stole it. Okay. Okay. So, anyways, just evaluating basically. There was stuff on using right triangles to rewrite the expression in terms of x. Maybe I should do one of those as well in my examples here. So, anyways, 4.7 is on page 626. If you're following along. 626. Number 3, I'm looking for sine inverse of root 2 over 2. Okay, so the spiel is you have to figure out the sine of what angle is equal to root 2 over 2. And your answer needs to be in between negative pi over 2 and pi over 2. So sine is positive in the first quadrant, so this angle must be in the first quadrant. If you think about your chart, it's pi over 4. Let's look at some more. Sine inverse of negative 1/2. So again, you're in between negative pi over 2 and pi over 2. It's negative, so you have to be in the fourth quadrant. And you're thinking the sine of what angle is equal to 1/2. And that's just pi over 6. But you're in the fourth quadrant, so you have to go negative pi over 6 to get there. 11. Cosine inverse of 0. Okay, and we're working from 0 to pi. Okay, and that's just going to be pi over 2. It's the only angle in that range that will give you cosine of pi over 2 is equal to 0. Let's try 17, tan inverse of negative root 3. Okay, tan is going like this. So it has to be in this quadrant. Anyways, tan of what angle equals radical 3? And that's just going to be the reference angle. It would be pi over 3. So we need the negative version because it's in the fourth quadrant. So it's negative pi over 3. Sorry, I put pi over 4 for some reason. Okay. Let's look at one of those other triangle type problems. So like 67. We have cosine of sine inverse of 1 over x. Okay, so the deal with this is to kind of reinterpret 1 over x as the ratio of sides of a right triangle, right? So sine is opposite over hypotenuse. So on our right triangle, opposite over hypotenuse. So in our case, 1 over x, right? So the opposite is 1, hypotenuse is x, and then use Pythagorean Theorem to get to the third side. So I have, 1 squared plus a squared equals x squared. Or actually, that would be the b side. It doesn't matter. But so b squared equals x squared minus 1 squared. 1 squared is 1. And then taking the square root on both sides, x squared minus 1 for this third side. Okay, so cosine then of this angle here is adjacent, which is square root of x squared minus 1 all over hypotenuse, which is x. So you should be able to do, let's do one more. No, let's not. Let's just leave it at that. Let's look at 4.8. Questions like 41 to 49. If you remember 4.7, there are all kinds of crazy questions that I kind of butchered in the videos, like tan of cosine inverse of 5/13. I'm not going to put one like that on there, where you kind of have to back engineer it and worry about all these technicalities. No, it'll be like these problems here. So basically for my tests, if you don't see it in my review, you're not going to see it on the test. They're pretty straightforward. I'll basically just go through the book, and worst case scenario, I'll pick out one that's similar to every problem I just showed you. So, from 4.1, I'll pick number Instead of number 19, maybe I'll pick number 20. Instead of 25, I'll pick 24. Instead of 45, I'll pick 46. Instead of 59, I'll pick 60. Instead of 71, I'll pick 72. Maybe I won't even put something like 73 on the test. I'll just skip those. There'll probably be about 20, 25 questions in that range. And basically anything on this review goes, but I'm not going to do anything that's not on the review. So don't worry if you didn't see it, it's not going to be there. Okay, so let's move on then anyways to 4.8. We're talking about pure applications. And let's look at the helicopter problem. And that should do us for this video. This is number 40 on page 638. Okay, so let me get over there first. Oh boy, 40. So it's not number 40, 46. So 46. A police helicopter is flying at 800 feet. A stolen car is sighted at an angle of depression of 72 degrees. Find the distance of the stolen car to the nearest foot from a point directly below the helicopter. Okay, so let's draw the helicopter here. Looks like I really like helicopters. We had a helicopter pilot in one of my classes once. He was like a test pilot for like the Marines or something, test piloted Black Hawks. And he saw some combat too. So. Okay, so there's our helicopter. It's flying above, and he was really good at doing math in his head, because helicopter pilots have to do all this math to make sure that they have enough fuel and stuff like that. So he was really great at that. Really smart. Anyways, we're flying above the car at 800 feet. Okay. This is our horizontal, and they notice a stolen car at an angle of depression of 72 degrees. So angle of depression is an angle down from the horizontal. So they're talking about this angle, and it's 72 degrees. And then they see the car. I don't like cars as much as I like helicopters. Helicopters are just so weird, They seem inherently dangerous. You can't turn on a car and accidentally kill somebody, but you can turn on a helicopter and accidentally kill somebody, They just seem just so crazy. Anyways, what we're after is to find the distance from the helicopter to the car, and we can use trig to figure that out. So what I noticed is, okay, the angle from here all the way around is 90 degrees. So to find this angle here, which I'll call theta, all you have to do is take 90 and subtract away 72. Okay, so theta is equal to 90 minus 72, which I think is 18 degrees. And then I note the tan of that angle, 18 degrees, as a ratio of sides of a right triangle, is d, the opposite side, over the adjacent side, which is 800. And then you could solve for d by multiplying both sides by 800. 800 tan of 18 degrees. The physics of helicopters are just really weird. The rotor and all that stuff. He tried to explain it to me, but it was just way over it was out of my pay. Whatever they say, it was above my pay grade. Okay, so anyways, this thing was, put in your calculator and go to the nearest foot. It's 260 feet. Please use units when you're answering our story problems. And I think that'll do us for the test. So a lot to memorize, a lot to memorize. And you want to kind of, as you go through this, identify, okay, I need to memorize this, I need to memorize this, and hopefully, you'll have it down by the day of the test. But yeah, a lot. I mean, trig is just memorization city. Okay. Okay. So we'll call that video quits there, and we'll see you next time.